morning one and all. Today I am discussing about basic geotechnical engineering 18Cv54 module 1 lecture class 2. The content of this today's presentation is formation of soil, regional soil deposits of India and phase diagram. Soil are formed, as I said in the last class, soil in an outer line, soil is formed by disintegration of parent rock by weathering. So here soil is obtained by weathering. So that is very clear. Then which agency which causes weathering play a vital role. So one is a physical weathering agency, another one is a chemical weathering. The chemical is the agency which causing the weathering. So what are the physical agencies which are causing weathering? So your air flow, wind, water current, rain, growing of some roots into the rock surface, and the borrowing animals which scratches the surface. All these things makes the detachment of top layer of the soil from the bottom layer, and these are all the responsible for weathering process. Therefore, it is called as a physical weathering. Then what is meant by chemical weathering? The chemical reactions which will going to take place on the surface of the rock, which are responsible for formation of the soil, is called as chemical weathering. So some of them are oxidation, carbonization, nutrification, which are responsible for formation of the soil by detachment of the top layer of rock from its rock surface. Next, based on whether the formed soil is resting on the parental rock or whether it is moved to some other place, again it is classified into two types. That is, one is called as a residual soil, another one is called as a transported soil. Residual soil means after the process of formation of soil, if it is rest on the parental rock itself, that means it is the rest on the origin of its formation, then it is called as a residual soil deposit. Whereas the transported soil deposit means after its formation, it has moved to some other area, there it get deposited and consolidated. Such a soil is called as transported soil deposit. Now question arises, which agency which has transported from one place to another place? So it may be a air, again it may be a flowing water, it may be a wind, so again it may be a gravitational flow. So based on that, the transported soils are again classified into alluvial soil, lacustral soil, colonial soil, etc. Alluvial means so it gets deposited by air. Lacustral means lake, it gets deposited in lake. Transported by water, deposited in lake is called lacustral soil deposit. So it may be a physical weathering or it may be a chemical weathering. Okay. So sometimes during the process of transportation and deposition, there will be some organic content get mixed with that soil, then that forms a muck or that forms a black, that is soil, or it is also called as an organic soil deposits. Now coming to the regional soil deposits in India. So in India we are classified soil into 6 groups. Number 1, marine soil, which occurs, as I am moving the cursor, coastal area of the Karnataka, Kerala part. So coastal zone soil. So these soils are marine soil deposit. The problem of this soil is it is very soft, contain rich in salt, therefore cohesive behavior is less. That means settlement is more. Number 2, laterite and lateritic soil deposit. Maharashtra, part of Maharashtra, Karnataka, parts of Telangana, Andhra Pradesh and Kerala, maximum portion of the Kerala, we can see lateritic soil deposit. Lateritic soil deposits are of two types. One is a low level laterite, another one is high level laterite. The laterite which are available on hilly areas called as high level laterite. The laterite which are available on low lying areas called low level laterite. So low level laterite means Mangalore side we will get the laterite. High level laterite means Kerala, Munnar, Tekadi, Alappi, those sides, on the mountain side we will get the laterite. So whether it is a low level laterite or high level laterite, as long as that lateritic rock which contains sap, it is a type of fluid, so that sap makes that rock very soft. Once that sap has removed, then it has exposed to the atmosphere, then it gains some strength. So that means it becomes very hard, the lateritic soil or rock. But during the process of that transition from soft to hardness, there will be some erosion of the soil, a rock surface takes place, that forms a soil, that soil is called lateritic soil deposits. So it has been calculated that 1 lakh square kilometer in India is covered by this lateritic soil deposit. What is the problem of this soil? The problem with this soil is when it is in dry state, it produces very good strength, whereas when it comes in contact with the water, it loses all its strength and it just flows like a water. Thereby, bearing capacity gets reduces, settlement will increases. So that is about lateritic soil. Third one is black cotton soil deposit. So Maharashtra, Madhya Pradesh, Uttar Pradesh, Karnataka, Telangana, Andhra Pradesh, Tamil Nadu, and traces of the Kerala, we can see very small traces of Kerala. We can see black cotton soil deposit. As the name itself indicates, it is black in color and it is good for growing cotton. Okay. So what is the area coverage? So it covers an area of 3 lakh square kilometers in India. What is the problem on this soil? This soil will have a peculiar behavior that is called as a swell shrink behavior. Swell shrink behavior means whenever it absorbs the water, it swells like a balloon. Whenever water gets released from the soil, it shrinks, but as the soil is not an elastic material, it is an elastoplastic material, during shrinkage it produces multiple cracks. We can see in Gulbarga, Bijapur, Gulbarga, Raichur, Davanagere region, somewhere we can see multiple cracks on the surface of the soil. This is because of black cotton soil deposit. And the swelling shrink behavior is caused because of the presence of one mineral. That mineral is in a clay which is called as a montmorillonite. So that mineral will have unbalanced surface negative charges, thereby it attracts the water whenever it comes in contact with the water. Problem of that soil is uplift pressure is very high. There are some circumstances where the low-lying area, that is the low-cost houses or lightweight structures like roads, small residential buildings, get lifted in vertically upward direction due to uplift pressure. So proper chemical stabilization is required. Next is the alluvial soil deposit. Central part of the Indo-Gangetic basin, Brahmaputra basin, we can see alluvial soil deposit. These soil deposits will have layer by layer soil deposition, like silt one layer, clay one layer, and so sand is another layer, etc. That means each layer will have different properties. Whenever we have each layer will not have coordination with the other layer during earthquake. So when a tectonic wave will hit one layer, only that layer will move. As a result of it, top layer gets collapsed and the structures which are constructed over the top layer subjected to distress. Best example is Bhuj 2001 earthquake is a live example for a disaster which is going to take place on such a type of soil. So the precautionary measures is we have to go for pile foundation, so or deep foundations. Next is Rajasthan, that is the sand deposits around 5 lakh square kilometer in Rajasthan area. Sand is available in all other places in India, but majority is available in Rajasthan, so is the desert soil deposit. The problem of this soil is it is a lack of cohesion. There is no bonding between the particles. It is a quartzite origin. Second one is though whenever wind blows, the sand dune formation takes place, thereby identifying the rigid zone, and firm ground is very difficult. So, and because of low moisture content in that area, dust accumulation is very high. Therefore, dust pellet tubes like calcium chloride spraying is to be required so that it will prevent the dust formation. So that is about your the desert soil deposit. So last one is boulder soil deposit. Boulder soil deposits available in Himalaya region on the top. So Nepal, Himalaya region. The problem of this soil is the laboratory test, whatever you do it, that will not reflect the actual behavior of the ground condition, because each boulder will have a different behavior that cannot be stimulated in the laboratory. So these are all about the regional soil deposits in India. So this is about the six different deposits in India. Coming to three-phase diagram. So soil consisted of soil solids, and between the soil particle there is a void space. If you take a soil, between the soil particle there is a void space. That void space may be filled by water, it may be filled by air, or it may be filled by both air and water. If it is filled by air as well as water, then that void space forms a partially saturated or partially dry. Such a diagram is called as three-phase diagram. Symbolically, it can be represented as a line diagram as solid, solid, soil, solid, water, air. So if it is the entire void is filled by water, then 100% saturated, then it is a two-phase diagram. If it is filled by air, then it is 100% dry, then it is also called as a two-phase diagram. So these are all the presentation, and thank you for attending the presentation. So please go through the multiple choice questions, and if you have any doubt, you can feel free to ask. Thank you for attending the class.